Hey guys, I thought I'd put together a few videos about each of the chapters that we've gone over for probability. One of the reasons is we've learnt everything remotely, so I thought it might be a good way to kind of consolidate and summarize everything you need to know. But also, a lot of people seem to have a bit of trouble with probability, so hopefully we can fix up some of those troubles with these videos. But we'll firstly go over chapter 13, which was pretty much revision from stuff we did last year and even before that as well. So firstly, I've got just your most basic rule of probability. So the probability of anything, and I've got event A here, it's a fraction. So down the bottom of the fraction is the total number of outcomes that could possibly happen. And up the top is the number of outcomes that satisfy event A. Now what we need to know is that all the probabilities of all outcomes, if you add them all together, they'll always equal 1. That's super important, and you're going to end up needing to use that a fair bit. Now, a lot of probability questions can be pretty wordy, and it can be hard for us to understand or try to get out or pick out the parts that we actually need. So something that I'd suggest that you do every time, especially if you have a bit of trouble, is draw it. Make sure you can see it. It makes it so much easier, I think. So there's a few different ways that we can kind of draw the scenarios that we'll see. One of them is tree diagrams, one of them is Carnoff map or probability table, whatever you'd like to call it, and Venn diagrams as well. Now firstly, let's look at tree diagrams. Now as it says down here, they're good for repeat events, and we multiply those branches to get the probabilities at the end. So up here, the probability that we work out at the top here would be that we've got, let's just say this is red. Maybe we're choosing coloured balls out of a bucket or something like that. The probability that we get red and then red would be timesing these two together, and we'd put our probability there. The probability that we get red and then not red, we'd times those two together and put our probability there. Same with those two as well. So remember, from up here, probabilities always add to 1. If we added that probability, that probability, that probability, and that one there, it should end up adding to 1. Now I'm going to show you a bit of an example of how we'd use a tree diagram here. Alright, so inside a container there are 4 black balls, 5 white balls, and 1 red ball. 2 balls are taken from the container, one after the other, without replacement. So this without replacement part is very important. The probability that no black balls are taken out is, alright, now we're taking 2 balls out, so we're pretty much doing a trial or repeating a trial, but the problem with that is it's not binomial because we're not replacing. So the probability that each trial is the same is not actually true. They're not the same. So I'm going to set up a tree diagram to help me see exactly what's going on here. Now there's black balls, white balls, and red balls, but the only thing we're after is to do with the black ones. Okay, so I'm just going to say whether we get black or not black. I could have 3 branches, but that's not really going to help me out. Alright, so that's my first trial. This would be my second trial. So on my second trial I could get black or not black. Could get black or not black. Okay, now let's just start from the beginning. So let's work out the probability that we do get a black ball. So there's 4 black balls, 5 white, and 1 red. That means there's 10 balls in total, and 4 of them are black. That means that of those 10 balls, 6 of them are not black. Okay, so let's go to the next part. Now, in all these little scenarios here, one of the balls has already been taken. So that means there's not 10 anymore, there's only 9 to choose from now. So that's out of 9. Cool. Now I'm actually going to stop what I'm doing here for a second because I'm working out the probability of all of these different outcomes. I don't need to know all of the different outcomes. All I want to know is the probability that no black balls are taken. So that would mean not black, not black. That would mean here. I'm only trying to work that out. So why would I waste my time trying to work out all of this stuff when I don't actually need it? Okay, so I only want that one. Okay, so we've taken 1 ball and it has been not black. So how many not blacks do we have remaining? We had 6, we took 1 away, so now we've got 5. Okay, so to get this probability here, the probability of not black and then not black, that's going to be that branch times that branch. So that's going to give us 30 on 100, which is 3 on 10. The answer should be B. Hopefully you can now see how tree diagrams can be helpful. With that situation, we didn't necessarily need to use the tree diagram, but it helped us to visualize it, which can help out a lot of people. The next thing we'll have a look at is probability tables. So we should have been introduced to this last year, so it wasn't new this year. It's basically a little puzzle. Okay, so we're just kind of aligning the rows and the columns. So this bit here, we've got A aligning with B. So this here would show us the probability of A and B. This one here, we've got B and not A lining up. So we could say the probability of not A and B. Then over here, we've got A and not B lining up. So this would be the probability of A and not B. And then finally here, we've got not A and not B lining up. So this would be the probability of not A and not B. Now it is a little puzzle sort of. So what we need to realize is that the rows and the columns, they sort of add up. So these two here will add up to make that. These two here will add up to make that. These two here add up to make that. These two add to make that one. And then we've got these two here, they add to make that. These two here add to make that. So what might happen in questions is you're given some of this information, and then you can use that adding up method to work out all of the other probabilities within this table. It can be really helpful. All right, let's move over to Venn diagrams. Now, I actually prefer Venn diagrams over probability tables because I feel like it makes it easier for you to actually see what's going on. So this is something that would have been introduced to you a long time ago, maybe like year 8 or something like that. Okay, so let's really quickly look at what each of these sections actually mean. So with these circles, everything inside here is B and everything inside here is A. But as we can see, there's a little bit of overlap or intersection here. So the probability that we'd put inside the middle is the probability of A and B. Right? Now, let's look at A. That whole thing is the probability of A, except this is included within A, isn't it? So I would actually say that this bit here is the probability of A and not B. Okay, so we've got everything that's A inside here, but nothing that's B. See how this section has some B in it? So we can do the same thing on the other side. So this would be the probability of not A, because there's no A in this section, and B. Now we can use that same sort of idea and fill in this outside section here. So this outside section would be the probability of not A and also not B. What we need to realize as well is that all probabilities, or the probability of all outcomes, will add up to make 1. So these are all different outcomes. We could get that one, we could get that one, we could get that one, or we could get that one. All of those things add up to make 1. So we could say 1 equals this plus that middle one plus the one on the right plus the one down the bottom. Now that's not necessarily any official rule that you'll be told to use, but hopefully you could see how that makes sense. I'm going to show you an example now of how we might be able to use a Venn diagram to help us out with a question that might seem a bit more complicated. Alright, so for the two independent events, A and B, the probability of A is 3p, the probability of A and B is p, and the probability of not A and not B is 5p. We've been asked to find the probability of P. Okay. Now, there's a fair bit of information that we've been given here, isn't it? So we've got the probability of A, we've got that, and we've got that as well. But it's also told us that they're independent events. All right, now I'm going to underline that one. Now, I haven't been over that rule just yet. We'll do that in a sec after this question. But if two events are independent, that means that the probability of A and B is going to be equal to the probability of A times the probability of B. All right, so if ever you see independent events, this rule applies. Now, we've got a heap of information here. I want to kind of sort that information out. I want to see what's going on, so I'm going to draw myself a Venn diagram. Okay, I've got my Venn diagram here. I want to put what I can into it. So I'm going to leave this for a second because this A takes up kind of two sections. It's that one and that one. But A and B, that is in here, and that the probability of that is P. The next one, probability of not A and not B, so that would be the outside section. That would be 5P. Now let's go back to A. So it's told us that the probability of A is 3P, so all here is 3P. 1P's already been taken up, so that means there's 2P's left. So we can fill that one in. We don't have this info yet though, do we? I'm going to try to work out what this is using this here. So it's told us that these are independent events, so this rule applies. I need to work out the probability of B. I've got A, I was told it. I've got A and B, I was told it. So let's work out the probability of B. Okay, so the probability of B is a third. Now the probability of B is a third. That means everything inside here is a third. I can't just put 1/3 there. I made that mistake before. That's actually wrong. This whole thing is 1/3. Okay, so if we've already got P in there, this is going to have to be 1/3 take away P. Cool, now we've got everything there. Now, the question that's actually asked us is to find the value of P. We can do that because we know that all the probabilities will add up to 1. That plus that plus that plus that is going to equal 1. Let's set that sum up and see how we go. There we go, so I've worked out that P is 2 on 21, which is B. The last thing I'm going to touch on for chapter 13 is some of these formulas that we've given and maybe some of the language that's used around them as well. So if ever you're told something is mutually exclusive, what that means is the two events have nothing in common. Okay, so if we look at our Venn diagram over here, if event A and B had nothing in common, that means there'd be nothing in this middle section. So that's why it's the probability of A and B equals 0. See how that's the rule there? So if ever you see the words mutually exclusive, I want you to just think immediately the probability of A and B is 0. because that's what they're trying to get at. The next bit here, and we did touch on this on the last question, is independence or independent events. And it means one event's unaffected by the other one. But honestly, I think you should just forget about that. Forget about what independence actually means. All I want you to do whenever you see that it tells you that two events are independent, this is the rule that you're thinking of. Okay, immediately. Next one, conditional probability. Right, so we would know that it's conditional probability if we see something like given that, if it says given that. So if we look at this rule here, this is pretty much saying what's the probability that the outcome is A given that it is B. Okay, so let's look over here. What's the probability that it is A given that it's B? So that's saying that it has to be B. So we're not worried about anything in here anymore. We're only worried about stuff that's inside B. What's the chance that it's A given that it's inside B? So if you look at these two sections here, this is the only other one that A applies to, isn't it? Okay, so that's why we've got the probability of A and B, which is this bit, divided by the probability of B, which is that whole bit there. So that's sort of how the rule works. The last rule that I'll touch on here is the addition rule. So again, this is something that you should be reasonably familiar with from last year. And you are going to have to remember all these rules, by the way. The addition rule is finding out A or B. So A or B means what's the chance that it's in that one, or that one. Alright, so let's have a look at the rule. It's saying that we've got the probability of A, which is all of this section, plus the probability of B, which is all of this section. So you might have seen that we've counted this middle section twice, but then it says take away that middle section. If we didn't take away that middle section, as I said, we would have counted it twice, and we'd actually have more than A or B. Okay, so it's important that we take that one away. I'm going to show you one more example where we need to use a couple of rules, because sometimes they are interrelated and we need to be able to kind of work that out. Okay, so for two independent events A and B in a sample space, we've got the probability of A is a half, the probability of A and B is 0.2. We want the probability of A given that B. Alright, now firstly, it's told us that the events are independent. So that means we've got the probability of A times probability of B is equal to probability of A and B. Hopefully we can already see that it's told us what A is, so we can put that there. It's told us what A and B, so we can put that there, which means we're going to be able to solve for probability of B, but let's just leave that for now. It's asked us to find the probability of A given that B. Again, hopefully we can remember the rules. The rule for A given B is the probability of A and B divided by the probability of B. Alright, let's look at this rule. We've been given A and B. We haven't been given B, but we can work it out from this here. So we should be all good in terms of finding A given that B. So let's start stubbing these ones in to find out the probability of B. Which equals 0.4. Cool, so we've worked out what B is, so we should be able to put that into there and that into there. Which is 1/2, so that would mean that our answer is D.